Welcome to AK App Logics. Today we are going to discuss about the interfacing LED to the Arduino. So let's start the video. So how to interface an LED with Arduino UNO. Here I have taken Arduino UNO. So let us interface LED to the Arduino UNO. I'm using the Wokwi website. So I'm gonna take the LED, okay, and place over here. And if you're gonna see, this pin is anode and this particular pin is cathode. I'm connecting anode pin to the pin number 13, okay, of the Arduino, which is a digital pin. Okay, in total in Arduino we have total uh, 0 to 13 digital pins. We total 14 digital pins we have. So I'm gonna connect pin number 13 to LED anode. Okay, to connect pin number 13 to anode of the LED, we have to use the resistance in between it, because an LED is capable of taking the voltage from 2 to 3 volts only. The LED can able to take, but the pin number 13, which is the digital pin, can give the output with the 5 volts value. So if we provide the 5 volts to the LED, then the LED will be burned. Okay, then LED won't work, so we have to use resistance. So generally we use 330 ohms resistor. Okay, use the 330 ohms resistor. I have selected the resistor and changing the value to 330 ohms. In this, if you want to see this, here we have ohms, 330 kilo ohms, but we have to take ohms. Okay, I'm taking the ohms, and you just bring this like this and press the R to rotate. Like this and press the R to rotate. So I'm gonna keep like this. Let me move this. So connect resistor to this and another end of the resistor to the pin number 13. Okay, now connect the cathode to the ground. Okay, so change the color. I'm going to change it to 0 for ground. Okay, this is the connections that we have made. So let us write the code for the this particular LED interfacing. So what we have to do is we have to take an integer to represent the value. I'm taking the constant int. Okay, constant int. I'm taking a variable as LED sorry LED pin. Okay, LED pin equal to which pin I have connected it to pin number 13, right? So pin number 13. So next we have two functions in the Arduino code. Those are setup function and the loop function. So the setup function executes only one time, whereas the loop function executes continuously after you dump the code into the Arduino. Okay, after you dump the code into the Arduino, the setup function is used to execute only once, whereas the loop function is used to execute repeatedly. So I have connected pin number 13 to resistor and resistor another end to anode of LED, and cathode of LED is connected to the ground. So all the digital pins can be worked as either input or either output. It can be worked as both input and output, but all the digital pins can't able to work at a time as both input and output. So we must have to tell whether the pin is working now as an input or now as an output. So we have to tell that thing. So for that thing we have a function, whatever may be, pinMode. It is a one function. Okay, so it is a function or method. Okay, we have to mention. So I'm taking LED pin, right? I have given variable LED pin to the 13, right? So LED pin comma, whether it is an input or it may be an output. So I'm giving, in this case it is an output, right? We should get the 5 volts to the LED, right? Okay, we have to send the 5 volts to the LED, so it must be an output. So I have declared LED pin to output. Okay, so it's completed. So to send the LED, we have to send the high, right? So I'm going to send high. For that we have another function, that is digitalWrite function, or maybe it will be treated as a method. Okay, it is digitalWrite. So uh, it is enough to declare only one time as an output, right? So I have mentioned pinMode function or the method in the setup setup uh, setup function. Okay, so only one time if we declare as an output, then till the next, when we declare as it as an input or any other type, so it will be treated as output only. So we need not to uh, tell every time, right? So I have declared in the setup. So whereas I'm going to give the value high. Okay, high in the sense 5 volts. So for that we have the function called function or the method we call digitalWrite, and for which pin we have to write the value high, that is LED pin, right? LED pin comma, what we have to send high means 5 volts. Okay, I'm going to send the high. So now it's been completed. So let us see, run the program. So I have given this means digitalWrite LED pin high. It means it should be high continuously, right? We have to supply 5 volts continuously to the LED, right? So I have given this particular digitalWrite method or function in loop function, whereas in pinMode LED output I have given it in setup function. Is only once if you declare it as an output, it will be treated as only output till you change next time. Okay, but where in the case of sending voltage, you have to send the continuous supply to the LED, right? So in our TV, if you on switch on once, and if you off the TV switch, it won't run, right? When the switch is on continuously, then only the TV will work, right? If the switch is on and immediately off, then the TV can't able to work, right? So that's the same thing. Whether you can treat an bulb in our home. Okay, to turn on the bulb, we have to must on the switch, and we have to keep that light like that only in the on state, right? So it means we have to give continuous supply to the bulb, then only the bulb can be able to turn on, right? In this case also, whereas LED should be high, or we need to send 5 volts continuously to the LED, then only we can able to say that LED, and then only we can able to expect the LED to be on. Okay, so that I have mentioned digitalWrite function in the uh, loop function. Okay, so let me run this program. It may take time. I am passing the video. Yeah, it's taking a lot of time. So let me discuss why we should take only 330 ohms resistance um, when we connecting the LED to the Arduino. So let me discuss that point. Okay, meanwhile let me discuss that particular point. Okay, yeah, if you're gonna see what I have told is, so let me tell you again. So if you're gonna see all the digital pins of the uh, digital, let me pause this and write. So if you're gonna see this, digital pin from all the pins, digital pins from the Arduino gives the 5 volts output, okay, for the high. Okay, so yeah, the operating voltage of LED, it will be varies for the each LED, red LED, yellow LED as well. So it will be around 2 volts. It may be 1.8 volt. Okay, we have to take minimum. Okay, we shouldn't take maximum as possible. And the forward current or the current that the LED can able to take forward, let me mention current that the LED can able to withstand is, it will be 20 milliampere. Okay, it is max. Okay, so let us treat it as 10 milliampere. Okay, so we have the formula to calculate the resistance, right? That is R is equal to V by I, right? So here we have the voltage difference, that is R is equal to 5 minus 1.8, 5 minus 1.8 divided by how much? 10 milli, 10 milli, right? So let me calculate this for you. If you calculate this value, we will get the 320 ohms. Okay, value, resistance value. But you can able to ask, instead of taking 330, it is better to take 320, right? You can able to ask the question like this. But the 320 ohms resistance is practically is not available, so that we have to take the nearest resistance value. So we take the resistance value as 330 ohms, which is practically available and which is nearest to the 320 ohms. So generally, while connecting the LED to the Arduino, we will use the resistance from 200 to 500 ohms. Okay, yeah, I hope you understood this. So let me go back to the simulation window. The code is implemented, so you can able to see the LEDs glowing. So let us do one thing, and also you can able to see the built-in LED is also glowing here. The built-in LED is assigned to the pin number 13, so that the built-in LED is also glowing with the this LED as well. So let me make this LED to turn on for every turn on and off for every second. Okay, so let me tell you a function or the method, another method, that is delay. So we are going to add the delay. We are going to give the delay, actually the delay will be in the milliseconds. Okay, so to give this to make LED to turn on off, to turn on and off, turn on for 1 second and turn off for 1 second, we have to give delay 1 second, right? So I'm going to give 1000. 1000 means I told, right, the delay will be taken in the milliseconds. Milli means 10 power minus 3. I have given 10 power 3, that is 1000, right? So 10 power minus 3, 10 power 3 will be cancelled, then we will get the 1 second. Okay, I hope you understood this point. So again, before we have given the high, right, to turn on the LED, now we have to give low to the pin. So let me give this low LED pin, comma, I'm going to give low to turn on the LED which is previously turned on. So let me rerun this code and observe. Okay, after you can able to give again. Okay, if you, this particular loop will be continuously executed. First it will be high, and after 1 second it will be low, and again immediately we can't able to observe the low. Why? Because again immediately it will go for the first step, that is high. It will turn on the LED again high. It means after this particular statement 11th statement, so immediately the ninth statement will be executed in the loop function. That is the meaning of the loop function. Okay, the loop function will be executed repeatedly infinite times when the power is given to the Arduino. Okay, the setup function is only executed only one time, so we haven't specified any delay in between this particular low and this particular high. Okay, so then you can't able to observe the low action. It will turn on only. So let us check by rerunning this code. So a lot of time is taking because the build server is load is very high. You can see over here it is very red. And so let me explain you this point. So let me increase the screen for you. So if you're gonna see over here, first this statement will be executed. Second, after one delay, the LED will be low. Okay, so immediately again it will return back to the starting point of the loop function, that is the ninth, right? So in between this particular thing and starting point of the uh, this particular code, there is no any delay. Even if you specified the low, there is no any delay. So that what happens is we can't able to observe the low state of the LED. So we must specify before digitalWrite high or the after digitalWrite low. We have to must specify the delay to observe that change. Okay, so our human eye can only able to observe the change of the state of an output. Okay, out output only uh, only seconds. We can't able to observe milliseconds, microseconds that much accurately. So if we gonna see over here the LED for the program that we have given, it is we can't able to observe the low state, right? Because our human naked eye can only able to observe only seconds. Okay, it can't able to observe the milliseconds or any other seconds. Here we didn't even specify the delay, right? So after digitalWrite low, we have to specify the delay, must specify the delay to observe that particular change. So I'm going to specify again 1 second delay. Why I have given 1000 means because previously I have told, right, the delay will be always in the milliseconds. See, the LED we can't able to observe the low state, okay, previously. So let me rerun this code. I have given delay, right, and check. So now what happens is the code we given is after high it will be in only high state for 1 second. After low it will be only 1 second in low and again goes to high. It means for 1 second the LED will be high, for another second it will be low. Okay, yeah, let us see the output. The code is uh, executing. Let me reduce the screen so and zoom this particular thing. So observe this. Okay, just a second. So I'm going to discuss this course as well so long. So there is a lot to learn in the Arduino. Let us discuss everything in detail. Okay, like this only I'm going to teach further classes also. So stay tuned to our channel. So let me stop this because it's so long. It's been 20 minutes. So let me stop this, pause this, and show you after the output get. See, if you're gonna see over here, the LED is getting on for 1 second and it is getting off for 1 second. So along with this particular external LED, the internal LED which is assigned to the pin number 13, as I told, right? So it is also getting turned on for 1 second, and it is also getting turned off for the another second. So you may ask me a doubt, okay, that is, sir, we have specified the resistor over here, which is connected to for the external LED, which is connected from the pin number 13, but we haven't connected any resistor to the built-in, it is called as built-in LED from the pin number 13. Why it is not getting damaged, sir, even though we are going to send 3 volts or 5 volts of supply to it? So the question is, in the Arduino, for the pin number 13, along with the LED, that is built-in LED, this one, we can also, it is also have a pull-up resistor, okay, pull-up resistor or the limiting current limiting resistor, okay. This particular thing we will call it as current limiting resistor, okay, remember the point, okay. So this is all about this lecture. Let's meet in the next lecture. So if you like this video, please like, share and subscribe to our channel. So stay tuned for more videos like this. So I'm going to explain in very detail. All I need is to invest your time in this. So I know it, the videos are so long, but if you invest more time in learning, then you can able to learn more, right? So I always believe in that. So invest more time, okay. So please like, share and subscribe to our channel, and for more videos stay tuned. So I think you got this video. So you practice by your own using the Wokwi website or the Tinkercad website, okay. If you have an Arduino board and the components with you, after only doing in these uh, simulators, you do with the real hardware components if you guys available, okay. So it's my suggestion for you guys, okay. Otherwise the board or the LEDs or the resistance may get damaged. The simulators are there for to test before implementing the hardware, to reduce the wastage cost or the damage cost, okay, or the to reduce our errors while implementing the hardware. So that's all about this video. Thank you guys. Bye.